to use the simple read sub-VI that can read a WAV file from your file system and then bring that into LabVIEW as an audio signal. I'm going to turn on the context help here, and let's just take a quick tour of the terminals. You'll see there's a variety of options available to you, and we can get by with actually just specifying the name of the file as far as a required input. So I'm going to do a right click and then create control, and this gives us a box that allows us to specify the path and the file name. And I'd like to listen to the result, and I'm going to do this with the ExpressVI entitled Play Waveform. Let's do a quick test. And as long as that beeps, then you know your sound card is configured correctly. So what I'm doing is wiring the output of my wave reading VI to my playback device. Well, let me try running this once first and see if we can enable that. Yeah, we haven't typed in anything yet, so that's why it's not finding it. Alright, so I'm going to start with an existing WAV file here. We see the full path and the file name have been entered. And of course when it runs, it reads the file and then makes that waveform available to the playback sub-VI. Now I'd like to be able to get out the audio data as a one-dimensional array instead of a waveform, and this will be useful for a lot of times where you're trying to get at simply the audio samples themselves. So the explanation here is that we have a mismatch between a 1D array and dynamic data. Now let's try deleting the link to the ExpressVI, which looks for dynamic data. Error still persists. Now it says we have a mismatch between a 1D array type and just the waveform itself. So let's try deleting that. And what I need to do is extract one of the channels coming out of our wave read device. Essentially this allows us to get at stereo channels, so we need to be able to specify which channel we actually want. I'll pick just a constant here, and channel 0 will get us started. So now we've extracted just a single waveform, and then I can obviously find that since the waveform player is not connected to anything, it doesn't work. So let's go ahead and reconnect that one back there. And what I'll do is go ahead and visualize the data using a waveform graph. So again, my idea is to simply grab a one-dimensional array, and then also I'll create an indicator here. This is called DT, and that's our sampling interval. Alright, that seems to work out pretty well. Now the sampling interval is clearly a small number, and what I'd like to do is perhaps get a little better idea of things like sampling frequency and other interesting parameters. So this sub-VI here allows us to get some information about the file. So I'll connect that up to the same path location. We can display things like the total number of channels. The sound format gives us our sampling frequency, total number of channels available, and bits per sample. Alright, so we again can see some nice information about the file that we're trying to work with. Now I'm going to try changing this to a WAV file that allows us to clearly tell whether or not we're looking at the left channel or right channel. Left channel, right channel. So hopefully you heard me say left channel on your left speaker. And we can confirm that we do in fact have 2 channels down there. So this particular version coming out of left channel, right channel, the waveform output allows us to actually see both channels simultaneously. And so we see left and in white, and right channel shows up in red. So what I'm going to do in terms of keeping our outputs as 2 distinct 1D arrays is I'll just copy my index array. I'll set that to index 1. Now let's see what we get when we apply our sound file to both graphs at the same time. Left channel, right channel. Alright, so it appears that the one called waveform graph is the one associated with our right channel. So I'm going to rename that one just for clarity's sake. And this is associated with our left channel. So again, index 0 gets left or monaural data, and index 1 gives us the right channel.